Hello students, welcome to RD Chemistry. If you are not subscribed RD Chemistry, please do subscribe, like the videos, share the videos and also write comment. In this video, I am going to explain nucleophilic substitution reactions. Students, you are already aware of the three types of reaction. First one is the reaction with the metals. Second one is the elimination reaction. Now third one is the nucleophilic substitution reaction. Students, what do you mean by nucleophiles? Nucleophiles are negatively charged species like OH minus, negatively charged, chloride, Cl minus, negatively charged. These are called the nucleophile. Any species that is negatively charged is called a nucleophile. Or you can also take water as the example. Water contains lone pair, correct? Ammonia NH3 contains lone pair. Any species containing lone pair is also called as the nucleophile. In the first case, these are negatively charged. In the second case, water and ammonia are neutral nucleophiles. They are neutral nucleophiles. Now, what do you mean by nucleophilic substitution reaction? For that, let me take carbon halogen bond. The valency of carbon is 4, right? Now, between carbon and halogen, halogen is more electronegative. Therefore, electron pair is very closer to the halogen atom and carbon gets partial positive charge. Therefore, the bond is a polar bond. This bond is a polar bond, correct? So, carbon halogen bond is polar bond. Suppose there is a nucleophile. Let me write it Nu minus. Nucleophile can attack the positively charged carbon and halogen can go out. So therefore we get now carbon attaches to the new group nucleophile and halogen atom goes out as the X minus halide ion. So replacing halogen atom by the nucleophile is called the nucleophilic substitution reaction. And X minus here is a leaving group. Halogen atom is a leaving group. Clear? Halogen atom is a leaving group. Now, we are going to take different types of the nucleophile. Like we are going to take OH minus, but in the form of sodium hydroxide, Na plus OH minus, nucleophile OH minus. Or water, H2O, is a nucleophile containing lone pair of electron. Or sodium salt of the alkoxide, ROH is the alcohol, sodium salt alkoxide, RO minus is the nucleophile. Potassium cyanide, potassium plus Cn minus, nucleophile is Cn minus. Potassium nitrate, K plus NO2 minus, nitrite is a nucleophile. Or silver cyanide, AgCN. Or silver nitrate, AgNO2. Lithium aluminium hydride. Hydride here is a nucleophile. Hydride H minus, anion of the hydrogen atom. Okay. Or alkyl metal. Alkyl metal. For example, CH3 lithium, methyl lithium, CH3 minus and lithium is positive charge. Therefore, R minus and metal is positive charge. So we are going to make use of all these nucleophiles for the reaction here. Okay. Shall we start now? So let me start with the first reaction. Alkyl halide or haloalkane, we write it as the RX bond, correct? Reacts with the, let me write sodium hydroxide, Na plus and OH minus. Hydroxide is a nucleophile. Hydrox attacks the R group. R is a carbon atom here, correct? And halogen goes out. So we'll write down the side product first now. Sodium halide is the side product. Na. Sodium halide is the side product. Plus, what is the main organic molecule? ROH. What is ROH? ROH is the alcohol. So we can convert haloalkane into alcohol. Haloalkane into alcohol using sodium hydroxide. Second one. Alkyl halide reacts with the water. Water is a H2O, correct? Containing lone pair of electron. I will not write the mechanism part, but I'll simply write a single step reaction. I can write water as HOH, correct? Side product is hydrogen halide. Hydrogen halide is the side product. Plus, we'll get ROH remaining part. So here we can also prepare alcohol using water to the haloalkane. Next one, third one. Alkyl halide reacts with the ammonia. Ammonia is a NH3, contains lone pair of nitrogen. So I can write this as the H and NH2. Side product is hydrogen halide. Side product is hydrogen halide. And the organic compound we are going to get are NH2. What is NH2? NH2 is the amine functional group. Clear? Right? Next one. Alkyl halide reacts with the potassium cyanide. Potassium plus, cyanide minus. If I had actual structure K plus and C carbon nitrogen triple bond. Therefore, negative charge is there on the carbon atom actually. So, this is a ionic species. Therefore, carbon containing the negative charge can attack the R group carbon atom and halogen goes out. So side product is a potassium halide. So product is a potassium halide side product and organic molecule is RCN, correct? RCN. So R is a alkyl, CN is a cyanide. Alkyl cyanide we are going to get. Alkyl cyanides are also called as the nitrile compound. They are also known as the nitrile. Cyanide is the common name and nitrile is the IUPAC name. Okay, clear. Next one, fifth one. Alkyl halide also react with the silver cyanide. Silver cyanide. But here product is different product. Side product is the AgX. Okay, expected as usual plus. But we'll get now not RCN. We'll get RNC. This is known as the alkyl isocyanide. Alkyl isocyanide. Or in other words, it's also called the isonitrile compound. Isonitrile compound. Now, why the products are different? Products are different because between silver and carbon atom of the cyanide, there is a covalent bond. There is a covalent bond. So, this is a covalent compound. Therefore, nitrogen containing lone pair. Nitrogen actually attacks the carbon atom present in the R group and halogen goes up. That's why you get a RNC compound and here Ag carbon bond breaks off later. Right? Therefore, remember cyanides you must have studied in a coordination compound. Cyanide is the ambidentate ligand. In this case, cyanide nucleophile is the ambidentate nucleophile. Ambidentate nucleophile. That's why the products are different. Potassium cyanide, remember, ionic compound. Attacks takes place through the carbon atom. Whereas the silver cyanide is a covalent compound. Attacks takes place through the nitrogen atom. Clear? That's why we expect different products here. Remember, in the first case here RCN, in the second case RNC, isocyanide. Clear? Sixth reaction, alkyl halide reacts with the potassium nitride KNO2, K plus NO2 minus. This is called the potassium nitride. Potassium nitride it is. Nitride. Okay, TRIT, nitride. Now, when I say potassium nitride, K plus, then oxygen, nitrogen, double bond O. Oxygen contains negative charge. Actually, the negatively charged oxygen attack the carbon in the R group. So, we get the product as RONO. So, we get alkyl nitride compound. Alkyl nitride compound. And side product expected one as usual. So, you get potassium halide. Remember, potassium nitride is the ionic compound here. It is ionic in nature. Okay, that's why you get alkyl nitride. Okay, now let me take a silver nitride. Alkyl halide reacts with the silver nitride AgNO2. AgNO2. Here we expect product like okay. So side product let me write first. That is the silver halide plus we get RNO2. RNO2. Now what is the reason for this? Between silver and nitrogen atom, there is a covalent bond here. Then there is a covalent bond between silver and oxygen atom, silver and oxygen. Then there is a N double bond. Okay. Nitrogen donates a electron pair. Now nitrogen attacks the R group. Okay. Even oxygen also contain lone pair, but nitrogen is more of nucleophilic. Oxygen is a more electronegative, cannot donate its electron pair, whereas nitrogen less electronegative can easily donate its electron pair. Therefore, nitrogen more nucleophilic. And we get the product. This is known as the nitro alkane. Nitro alkane compound. NO2 group. Okay, bond NO2 called as the nitro compound. So it is called the nitro alkane. Okay. Here also remember, nitrite is a ambidentate. Is a ambidentate nucleophile. Ambidentate nucleophile. Okay, ambidentate nucleophile. Either oxygen can donate or nitrogen can donate. It's a electron pair or the negative charge. Right. Next one, eighth reaction. Alkyl halide reacts with the silver salt of the carboxylic acid. Carboxylic acid is RCOOH. So I'll write RCOO minus. Silver salt of the carboxylic acid. Silver carboxylate it is. Okay. This is the silver carboxylate. This is the silver carboxylate. So where is the nucleophile? Here it is. So RCOO minus attacks the carbon of the R group and halogen goes out. So side product is now which one? Side product is the silver halide. Now there are two R groups. So let me change this R as the R dash. Okay, so therefore I'll get R dash COO. Now that attaches to the R of the alkyl halide. So here there is a function group. This function group is called as the ester. So we can also prepare esters here. Clear? Right? Next one. Ninth reaction. Alkyl halide reacts with the lithium aluminium hydride. Remember, hydride means H minus. Okay, this is the hydride. Hydride is a nucleophile. Nucleophile can easily attack the carbon atom. Halogen goes out. Okay, so we'll write RH now. Okay, now what will happen to the lithium? Lithium halide is formed. Lithium halide, correct? So lithium Li plus X minus. So LiX. Then silver aluminium halide. Aluminium valency plus 3. Halide is minus. Okay, therefore AlX3. So we'll get AlX3. But how many hydrogens are there? Hydrides are there? 4. So I'll get 4 RH. Okay, 4 R groups are there. Therefore 4 R. How many halogen atoms are there? 4 are there. So here lithium halide 1 and aluminum halide 3. So altogether 4. So equation balanced. Now what is RH stand for? RH stand for hydrocarbon. 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 Like R is like generally CH3, methyl, ethyl, propyl. So the CH3, one hydrogen attached. We get here methane, one of the alkane, correct? So in general, I can write the hydrocarbon. It can be alkane, alkene, alkyne. So we get a hydrocarbon, right? The last nucleophilic substitution reaction is, okay, alkyl halide reacts with, okay, alkyl metal, alkyl metal. For example, methyl lithium, methyl lithium. Methyl is a negative charge, lithium is positive. Metal ions are positively charged. So nucleophile R minus attack the R. Okay. So I have written as the R and R dash, two different R groups. So if I'll get R dash, correct? Plus metal halide we get. Now what is R dash? It is also hydrocarbon. Higher hydrocarbon. Methyl plus methyl together. Like, okay. So they are the higher hydrocarbons. Clear? So all these are the different types of the nucleophilic substitution reaction. So you have to identify the nucleophile present in the given reagent and attach that to the alkyl R group in the alkyl halide or haloalkane. Clear? So we are done with the three types of the reaction under haloalkane, reaction with the metals, elimination reaction, and third one is the nucleophilic substitution reaction. In the next video, I'll explain two mechanisms under nucleophilic substitution reactions. Clear? Like the video, share the video and subscribe RD Chemistry and support me. Thank you for watching.